Hello, it's Mrs. Grizafi again, and we're on 11.05 pre-calculus today. These notes are called the tangent line problem. So we're going to start today's notes with kind of just a little talking about the concept, because this topic we're talking about, which is derivatives, is really, really important for calculus. So if you continue on in calculus next year or at some point in the near future, then this is a really, really important topic to know and kind of understand. And when you get to calculus, you're actually going to learn a lot faster way of taking derivatives. But for pre-calc, our goal here is to really understand the formula and be able to utilize that in finding our derivatives. So first, we're going to look at the line tangent to a curve. So if we take this curve right here, we can't find the slope of this curve, this blue curve, because it's not the slope or the rate of change is not constant for a curve. It's only constant for a line. So the slope of a line indicates the rate at which a line rises or falls. For a line, this rate is the same at every point. So no matter what 2 points we take off this line, and we do change in y over change in x, that will always give us the same number. So in Algebra 2, when you guys talked about average rate of change, you found that the average rate of change of a line it's always the slope, and it's always the same, no matter what 2 points you take. For graphs other than lines, like this blue curve, the rate at which the graph rises or falls changes from point to point. So we can't just find any 2 points and take the slope of them, because it's going to be different depending on what points you take. So to determine the rate at which our graph rises or falls at a single point, we're going to find the slope of the tangent line. And you guys talk a lot about tangent, a little bit in Algebra 2, but in geometry, you talk about with circles, a tangent line is a line that would hit that circle exactly one time. So it's tangent to the curve. It'll hit it at exactly 1 point. No more, no less. So to figure out this slope of the tangent line, we have an issue because a tangent line hits only 1 point. And in order to write the equation of a line, we need 2 points. So I'm jumping down to this bullet here. We need 2 points to find the slope of a line, or an equation of a line. So to approximate the tangent line, we're going to make use of a secant line. And again, you'll remember from geometry, if you have a circle and a secant line, your line is going to cut through that circle 2 times. So if we take the point of tangency and then another point somewhere on that curve, then we'd have 2 points making up our secant. So how are we getting these points? Well, to derive our formula, we're not going to use numbers. We want to talk in general. So these 2 pictures that you see, the 2 different boxes right here, they're the same thing. They're just showing it a little different way. So I put them both on in case one makes more sense than the other. So for the first point, we're going over x. So from here to here is x, some amount. And then we put x into that whatever function that is, and it gives us f of x for our y value. Then we go over some amount. We're going to call that amount h. So this new x value is going to be x and then plus h. The y value is going to be whatever our function is at x plus h. So you can see that over here again. So here's your point is x, and then f of x is your y value. This point is x plus h, and then the y value is f of x plus h, and there's our secant line. So our point of tangency is our x comma f of x, and our second point on the graph is going to be x plus h comma f of x plus h. So these 2 points right here are coming from these 2 points that you see on these 2 pictures. So if we want to find the slope of them, we're going to do change in y over change in x. So I'm going to take, so this is like my x1, y1. This is my x sub 2, y sub 2. So we're doing y2 minus y1 over x sub 2 minus x sub 1 to find the slope of our secant line. So we would take f of x plus h is my y2 minus my y1 is f of x over my x sub 2 is x plus h minus my x sub 1 is x. And then, so this is our slope. So then the top, there's nothing really I can do to simplify this when it's in terms of the function. But the bottom, I can cancel out those x's, leaving me with just h. So our formula for the slope of the secant is f of x plus h minus f of x over h. So that's the slope of our secant line. So again, why we're doing this. We're trying to find the slope of our curve or at a certain point. So in order to find the slope at a certain point, we need to find the slope of our tangent line because that they would share that point. Well, we need 2 points to write the equation of a line. So we say, okay, well, let's take that point, that tangent point, but then we need another point on our curve. So we find another point. That is h away from this one in terms of our x value. So we can now find the slope of our secant line. So that's all we've done so far. So how does finding the slope of our secant line help us to find the slope of our tangent line? Well, here enters limits. If I can scroll to the second page, that is. Okay. Sorry about that. So on the second page, you'll see, I'm just going to give this a second here to regroup. We're going to be talking about the actual derivative. So if you can look at, now I've lost my first pictures too. If you look at the 2 points, now we want those points to become one single point. Here we go. So we want that secant, I'm actually going to go back up here again. I want this distance, between the two, this h value, I want that to get closer and closer together so that eventually h is 0. Because if the h is 0, that means there is no distance between x and x plus h, if h is 0. So this is when we use a limit, because we want to know the limit as h becomes so small that h is 0. So we want to know what that value would be if we take these 2 points from our secant, and we want to know what's going to happen when they become 1 point. And that point has to be that point of tangency. So our definition of a derivative. The slope of the graph at the point x, comma f of x is equal to the slope of the tangent line at the same point, which is given by this right here is your slope of your secant. But once we take the limit as h approaches 0, now that is the slope of your tangent line, also known as your derivative. So we're taking the slope of the secant and taking the limit as h approaches 0. The slope of a function is known in calculus as the derivative. We also write derivatives with this little prime symbol here. So like f prime of 3 is the slope of the function of f of x at x equals 3. Or you could say it's the derivative of f of x at x equals 3. So this f prime of x is another way of saying the derivative, just our symbol for the derivative. So in this picture, you can kind of see here, I was just trying to show you that we're taking these 2 points. So this is your tangent right here, your tangent point of tangency. And we're taking this secant line and we're just bringing it closer and closer until eventually h is 0, so there's no distance. So we want to know what is the slope at this specific point right here, this point of tangency. We can't find it with 1 point, so what we do is we take 2 points, and then we take the limit as the distance between them becomes 0. So again, limits just mean what it's approaching. So what are we getting closer and closer to as the distance between them becomes 0? Let's take a look at how we can actually use this. So that's really just the concept behind these derivatives. So I'm going to show you a couple different ways of how I could ask the same thing. So we could ask it as the slope, we can ask it as the derivative, and we can use our symbol notation, the f prime of x as well. So find the slope of the graph of f of x equals x squared minus 4x at the point 3, negative 3. So to find the slope, we want to find the slope of our tangent. So first, I'm not even going to worry about this point where it says at the point 3, negative 3. My first step I want to do is I want to find the slope of the tangent. So to find the slope of my tangent, I'm going to take the limit as h approaches 0. Again, very important that you write this part down, of f of x plus h minus f of x over h. So this part right here, that, oops, don't want a highlighter, is the slope in this box right here. That's your slope of your secant. And we're taking the limit as h approaches 0 of that slope. Okay, so now we're going to substitute in here. So this is where it gets a little more complicated. I know the concept is already a lot to kind of wrap your mind around. So we've done a little bit of this without knowing that that's what we were doing. So now we're going to find f of x plus h. So here's f of x. Everywhere I see an x, I'm going to replace it with x plus h. So I have so far x plus h for this x squared minus 4 times x plus h. So that's my f of x plus h, this part right here, minus f of x. So I'm going to do minus, and then make sure you put that in parentheses because we're subtracting that entire thing. So f of x, I already know what that is. It's this thing. I don't have to change anything about it. All over h. All right, so now that's kind of the hard part of substituting in our x plus h, subbing it all into our formula. Now we're just going to do kind of more tedious work with simplifying. So limit as h approaches 0, make sure you write that every time. We're going to FOIL this first part out right here, the x plus h quantity squared. So if you need to off to the side, you can write that out twice and FOIL that out together. So x squared plus xh plus xh plus h squared. So it's going to give me x squared plus 2xh plus h squared. Next, we'll look at this part right here. So I'm going to distribute the negative 4 in. So I get negative 4x minus 4h. And then this is like a negative 1 right here. So don't forget to distribute that negative. So negative x squared, negative 1 times negative 4x would give me a positive 4x all over h. Let's continue to simplify. So now we have the limit as h approaches 0. And what can I cancel out here? Well, I've got x squared minus x squared. Those are going to cancel. I've got negative 4x and a positive 4x over there. So I am left with, and I'm going to put this into standard form when I rewrite it. So h squared plus 2xh minus 4h all over h. All right, so not much I can do here, except I have a GCF in my numerator, so I'm going to factor that numerator out. You could also think about dividing each term individually by that h as well. So if I factor out an h, I'd be left with h plus 2x minus 4 over h. The h's are now going to cancel. and I have the limit as h approaches 0 of h plus 2x minus 4. And from here, I can now use direct substitution. So I can put in a 0 in for my h. So I have 0 plus 2x minus 4. So it just gives me 2x minus 4 for my derivative. So that means, I'm just going to go up here a little bit, f prime of x, so the derivative at f of x equals 2x minus 4. Okay, so now we've found the slope of our tangent line, we've found our derivative. We were asked to find what it is at this specific point. So what they're really asking me to find is the derivative, and I actually don't care what the y value is, I only care what the x value is, so f prime of 3. And to do that, I'm just going to sub in a 3 in for x. So I've got 2 times 3 is 6, minus 4 is 2. So the derivative of f of x at 3 would be 2 for my final answer. Okay, so a lot of work to answer this question. Again, you're finding the slope of your secant, taking the limit as h approaches 0, substituting in x plus h in for f of x first, minus whatever f of x was all over h. Then we FOILed out, combined our like terms, reduced, then used direct substitution to find the limit, which gave us 2x minus 4 for that limit. That was our derivative or our slope of the tangent. And then we subbed in a 3 in for x to find f prime of 3, or f, the derivative of f of x at 3, to be 2. And then, as you'll see in calculus, which right now I want you guys writing everything out, but what it does is kind of like the swoop rule for our logs. The 2 comes to the front here whenever you have an exponent. So it becomes 2x minus 4, and whatever has a variable. If it's just a 1 exponent on the variable, then that variable will go away for the derivative. So they're actually a lot of fun to do the short way of them as well. So I hope you guys enjoy them in calculus too. This way is a little bit longer, a little more tedious, but also pretty rewarding when it works out, which is kind of cool. All right, let's try another one. So number 2, given f of x equals x squared minus 2, determine the following. So f prime of x, which means the formula for the slope of the graph of f of x, also known as the slope of the tangent line, also known as the derivative. Then part B says determine the slope at 1, -1, so at a specific point, and then also at x equals -3. So again, lots of different ways of saying the same stuff. So I tried to show you all different ways so you'll be prepared for any way the question asks. So first we're going to find f prime of x. So to do that, we're going to write out our formula. So we're going to take the limit as h approaches 0 of f of x plus h minus f of x, which was our change in y, over our change in x for our slope of our secant. And then we take the limit, which makes it the slope of the tangent, which makes it our derivative. Now I'm going to substitute in. So I've got limit as h approaches 0. So this is my f of x. So for the first part, I'm going to sub in x plus h. So I have x plus h, and for the first x, that whole thing is squared, minus 2. And there's no x there, so I just leave it at minus 2. So that's this first part right here. Then I have minus f of x. So minus f of x, I already know I don't need to change anything about it. All over h. Okay, so that's the hardest part, knowing your formula, substituting in. Now it's a matter of simplifying, a lot of FOILing, combining like terms, things like that, reducing. So I'm going to FOIL this out first. So x squared plus 2xh plus h squared. That's this squared. If you need to, again, feel free to write it off to the side, FOIL it out, combine your like terms, pause if you need to get yourself caught up to make sure you understand where I just got this from. Minus 2. And then in blue, we're going to distribute that negative. So it'll be minus x squared plus 2 all over h. Now it's time to combine our like terms. x squared cancels with the x squared, negative x squared. Got negative 2 cancels with a positive 2. So now I have the limit as h approaches 0 of h squared plus 2xh over h. So you can divide up into here to divide out the h from each of these, or you can think about it as factoring out your h first in the numerator, and then your h's will cancel, and we're left with h plus 2x. At this point, we can now use direct substitution. So sub in your 0 in for h, since it's h approaches 0, it's not x approaches 0. So we get 0 plus 2x, which is 2x. So the derivative of f of x is 2x. Again, that quick trick from calculus, it's like that swoop rule. Swoops to the front, and then whatever's up here, you subtract by 1. So 2 minus 1 is 1. And then since negative 2 doesn't have a variable, it just disappears. I'm not expecting you to know those quick tricks. I'm not going over those right now. Some students just pick up on those really quickly when I mention it, and they like to use it as a little check for it. So if that makes sense to you, you can do that. I am not asking you to do that or understand that at this point. But even if you do understand it, I do want all of this work written out. I'm looking for this long way of doing them. I know there's a shorter way, but I want you to understand where that short way is coming from and this formula, which is really important for next year. Okay, and then part B says to find the slope at the point 1, negative 1. So really, what's that asking us to find? Well, it's asking us to find the derivative at x equals 1. We don't care what the y value is. We just want to know the derivative at the x value. So I'm just going to sub in 1 in for x. So that gives me 2. And then part C, pause the video, see if you can do it on your own if you understand what that means. All right, so hopefully you just subbed in negative 3 in for x, and you got negative 6 for your answer for C. All right, and number 3, given f of x, find f prime of x, or find the derivative is what it's asking, or find the slope of the tangent. So all different ways of saying the same thing. So to do that, we first need our formula. So the derivative of f of x equals the limit, and this is the part people forget to write, is the limit as h approaches 0. It's so important because you're not just finding the slope of the secant, you're finding the slope of the tangent. And it's f of x plus h minus f of x all over h. And we're going to write that out every time. So first we need to find the expression to represent f of x plus h. So everywhere we see an x, we're going to put in x plus h. So this is right here, so I'm going to do that in brackets. So I've got 3 times x plus h, because I take out the x, replace it with x plus h squared, minus 2x, so I take out that x, replace it with an x plus h, minus f of x. Well, f of x stays the same, 3x squared minus 2x all over h. So now we've subbed in our x plus h and our x. Now it is time to simplify. So we have the limit as h approaches 0. In this set of parentheses here, I have 3, and then we've done this one a couple of times. So again, I'm just going to write it out, but if you need to go off to the side and do x plus h times x plus h, that's fine too. I'm going to distribute my negative 2. So negative 2x minus 2h. And then in blue, I'm going to distribute my negative 1 here. Don't forget to distribute that negative. Super duper important. All over h. All right. Now I'm going to distribute my 3 into this set of parentheses. So I've got the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. Let's combine some like terms here. I've got a positive 3x squared and a negative 2x, and a positive 2x. And I'm left with 3h squared plus 6xh minus 2h over h. And now I can divide up that h from everything. So I'll get the limit as h approaches 0 of, actually, let me continue doing it the way I was doing it. So I was factoring out the h from each. So it'd be 3h plus 6x minus 2 over h. Then our h's will cancel. So I have the limit as h approaches 0 of 3h plus 6x minus 2. Now I can use direct substitution. 3 times 0 plus 6x minus 2 is 0. So I get 6x minus 2 for my final answer for the derivative. So again, to double check that, I would swoop this to the front. 2 times 3 is 6. Subtract 1 minus 2. Looks good. All right, and our last one, a little bit different. I threw in a radical here. So find the derivative. So again, that means the same thing as find f prime of x, which is our derivative. Find the slope of the tangent line is what we're doing again. All right, so we find our formula first, which hopefully you're starting to have this memorized. Remember, the subtraction symbol goes between them because you're finding slope. You're finding the change in y, y2 minus y1. So that's how I remember. That's minus, and then inside the parentheses is plus, because you're adding h to the x. Okay, so for this, we're going to take the limit as h approaches 0, and we're going to, here's our f of x right here. We're going to sub in our x plus h first. So, because we're going to do, we'll do that in red. So in for x, I'm putting x plus h. So my only x is right there. Minus f of x, so nothing's going to change there, all over h. Okay, let's combine our like terms. We don't have to FOIL here, which is nice. So I've got, for some reason that skipped a lot of space, sorry about that, x plus h plus 1. Let me rewrite that for you. X plus h plus 1 minus, and we're distributing our negative here, minus rad x minus 1 all over h. And we can see here that our 1's are going to cancel. So I get the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Now, from here, I could try to do my direct substitution, but if I do, I'd get rad x minus rad x, which is 0 over 0, my indeterminate form. So that's no good. When we get our indeterminate form, we're going to multiply the numerator by our conjugate. So we take the conjugate of our numerator and multiply both the numerator and the denominator by that conjugate. And let's FOIL out the numerator. So I get rad x plus h times rad x plus h. When I multiply a radical by itself, it just gives me whatever's underneath the radical. Then here I'm going to have plus x times x plus h. They're both under radicals. The middle will subtract that same thing. Again, they're both under radicals, so everything can just get multiplied underneath the radical, and rad x times rad x gives us what's under the radical, so minus x all over h. Now I've got these two cancel here. X minus x cancels over here. And oh, I forgot to multiply my denominator. And I'm going to keep that in that factored form. And now my h's will actually cancel out as well. I'll write that out for you so you see what I mean. So in the top, I just have an h. In the bottom, I have h times the square root of x plus h plus rad x. So now these cancel out, leaving me with the limit as h approaches 0. I have nothing in the top, so that must mean I have a 1 over the square root of x plus h plus the square root of x. Now let's try our direct substitution. So x plus 0 gives us x. Again, you're subbing the 0 in for the h, not the x, because it's as h approaches 0, plus rad x. Ooh, and now I can combine rad x plus rad x to get 2 rad x. You never want to leave your radical in the denominator, so we're going to multiply the top and the bottom by rad x for our final answer, and we get the square root of x over 2 times x. Square root of x over 2x, that is your final answer. So for this one, the derivative of f of x is the square root of x over 2x. So those ones are a little trickier to do the faster way. And that fast way gets very complicated too as you learn more and more about the derivatives. So that is it for us for today. You guys will have a homework on this, and then next class you'll have a classwork assignment on the same stuff, because it is really important that you really understand it. So we'll spend an extra day on it as we start to wrap up about our limits stuff. So I hope this makes sense. I know it's a very heavy lesson. There's a lot of concepts there, a lot of tedious work that's going on. So if you do have any questions at all, please let me know. And I hope you're all doing well and working on those math dances. And I miss you guys. And hi out.